Okay, here we go. So this is what you would normally see. In the beginning, I'll give you kind of a rundown of what we're reviewing in that session, and what the topics are going to be, and so on and so forth. And I'll give you, we kind of went through a lot of this stuff already, lecture materials, lab materials, and so on, and the recordings, and so on and so forth. Okay, lab study designs. I'm going to go into here. Statistics. So I'm going to just quickly try and. So this is Thursday.
Yes.
This is, how many classes have we had?
Just two. This is our second.
I know, that's bizarre, isn't it? Yeah, because we had one class on Thursday, and then we had a week off because Monday was Thursday, and that dance and so on and so forth. I gotta get my head around where we are, because it's, I have other classes. I'm up to my third or fourth session with them. Okay. Yeah, I get it. Let me just take a quick look back last week. Yeah, unfortunately, I was supposed to be turned on. But at any rate, I'll make up for that now. So yeah, again, I'll give you a rundown. I'll give you some readings, usually some chapters that you might read. There'll be lecture materials. If you click in there, there'll either be a recording of me giving a lecture from a previous semester, or some recording that I made separately, or it could be another professor and so on. Then there'll be laboratory material. Basically, by lab, I mean exercises, actual application, like from week one. This is from last week. This is the recording of what we did in this classroom last week. A couple of you were here last week, so if you want to review what we did, you can actually play this back, and the material for the exercises that we did. I don't blame you, it's late, right? Okay, all right, good. So I am going to assume that we remember nothing from 2 weeks ago. Obviously, I don't remember anything from what we did 2 weeks ago, so I'm going to assume that you guys are in the same boat, because it's been a long time. Okay, and I'm going to start off with some of these lecture materials. Okay, see what we got.
So week 2, part 4 isn't visible yet.
No, it was also grayed out still.
I only see week 2 lecture materials.
Okay, I'll get back to that in a second. Lecture materials, yep, that's hidden. It's hidden because that's a video there, and I was going to redo it now.
Oh.
Yeah, I kind of hid it on purpose. Well, maybe not on purpose, but maybe not completely on purpose.
There was a reason.
Yeah, exactly. It may not be a good reason, but there was a reason. Okay. Okay, so let's talk about, in our first session, I know that we covered data types. And I emphasize, data types are really important. I mean, it seems silly. It seems like a trite thing that, like, that you have these different forms of data, and that, like, just the way just what you call them is meaningful. Okay, but it really is meaningful. So, for instance, we know that SPSS, for instance, breaks down data types into 3 primary types. It calls them scalar. That's the word SPSS uses for it. I'm using that word because as we go forward, not so much in the beginning, but as we go forward, we're going to use SPSS quite a bit. So it pays to kind of get into their nomenclature a little bit right from the beginning. So they refer to 3 types: scalar, nominal, and ordinal. Okay, so scalar is a scale, numbers, numerical data. Okay, you can call it numerical data, scalar data, and so on and so forth, but it's numbers, right? It's measurements: weight, BMI, blood sugar, blood lead levels, and so on and so forth. They're numbers, and the numbers are typically on a scale. Okay. And that scale might start at 0, might not start at 0, but it's a continuous scale. There's another kind of numerical variable, which they don't really separate in SPSS. They call them any numerical variable, they call it scalar. but that's called a discrete numerical variable. Anybody know what the difference is? Right, integers, like something you count. If you think about something that you would sit there and count, right, that's typically a discrete numerical variable. In most cases, you probably treat them pretty much the same. At least at our level, you'd probably wind up treating them mostly the same in terms of how you would handle them. But there's a certain way we handle numerical data that's different than the way that we handle these other kinds of data. So let's talk about the other kinds of data. Nominal data. Sometimes you'll call it categorical data, because nominal data just means names, things that are names. For instance, literally, a nominal variable, one type of a nominal variable might be a last name. Another one might be a first name. Another one might be a hair color. Another one might be gender, male or female. Another one might be left-handedness, yes, left-handed or right-handed, and so on and so forth, right? So anything that has a name and is not a number is a nominal, or you could call it categorical variable. Okay, so both of those, you can use both those terms interchangeably. I think SPSS pretty much sticks with nominal. Okay, now how is that different than numerical variables? Well, for instance, numerical variables, their numbers generally the numbers are very different. Could be 29, 34.1, 36.7. In order to organize those, in order to understand how those numbers are distributed, how those numbers are laid out, especially if you have really a lot of them, typically with numerical variables, we want to know where the middle of the range of numbers is. In other words, if we take a classroom, we randomly sample students, sixth grade students, and measure their height, for instance. When we get a bunch of numbers, when we get 100 numbers together, we randomly sample 100 students that are in that age group. We have 100 numbers. We can't really interpret that list of numbers, right? Because all we're seeing is a blur of numbers. But the way we might organize it is say to ourselves, well, number one, where is the middle? What's the average height for kids in that age range, right? So we would take the average. That's called the mean. In statistics, the arithmetic mean is called the average, is the mean rather, right? So we'd be interested in the mean. Another measure of where the middle is called the median, right? So the median is the 50th percentile. It's the person that's in the middle of this whole group of 100 kids. A lot of times the median and the mean are the same, or at least very close. Sometimes they're not, but most of the data we're going to be working with, we're going to probably find that they're pretty similar, the mean and the median, the middle value. Okay. Then we want, now that we know where the middle, well, there's another variable that we use sometimes called the mode. The mode is the most frequent value, right? So in other words, in the case of heights, if we only took one, if we only measured it in inches, so for sixth graders, the mode might be, I don't know, 58 inches, let's say, something like that. That's the one that number comes up most frequently. Mode is not quite as good a measure as median and mean are, right? But sometimes it comes in handy. It's interesting to know what the most frequent value is. Okay, that's interesting. We have three ways of measuring the middle, where the middle is in a bunch of numbers. Okay, the other thing we're interested in, how spread out are they? What's the spread like? The simplest way to describe the spread is look at the lowest value and look at the highest value. That's called the range. Minimum value, difference between the minimum value and the maximum value is called the range. The other thing that we might actually measure that we might be interested in, that gives us an idea of the spread, is the quartiles. In other words, where is the 25th percentile? Where is the 50th percentile, the median? Where's the 75th percentile? And where's the lowest number and the highest number? 0, 25, 50, 75, and 100. And that middle 50%, that 25th percentile to the 75th percentile, what's the range for the middle 50% of the people that we surveyed? That's called the interquartile range. We're going to get to a slide where you're going to get a picture of it, but I just want to give you a preview the idea of these variables and why we're so interested in the type of variable. Okay, so that's for numerical variables. Well, how about nominal variables or categorical variables? Well, they're not numbers. It doesn't make sense to find a mean for left-handed and right-handed. Maybe a proportion, 30% of people are left-handed or something like that. But for the most part, you're doing frequencies, you're counting people that are left-handed, counting how many people are left-handed, how many people are right-handed, how many people have red hair, brown hair, black hair, blonde hair, right? How many people are in those different groups? How many people are males? How many people are females? So with nominal or categorical variables, frequency is probably our most important measure of how that information is distributed. Okay, so that's categorical nominal variables. There is another kind of variable, which is a special form of name, special form of nominal variable. And that's when the name has the values for the name, instead of like hair color being, blonde, brunette, redhead, so on and so forth, instead of the name just, describing something, that name may have some value, the values that name, that nominal variable can have, even though they're names, they can have some relative value compared to one another. So for instance, if I were to rate this course poor, fair, good, those are words, right? So in other words, you survey a class and 25 said good, 14 said fair, 1 said poor, 10 said excellent or something like that. You're counting it just like a nominal variable. You're treating it just like a nominal variable. But there is an interesting difference, and that is that you can kind of put them, that there's kind of a natural order to them. Fair is better than poor. Good is better than fair. Excellent is better than good. And so there's a natural, even though it's a name, there's a natural order to them. A really common one that people use is the pain scale, right? So in other words, I ask you, what's your level of pain from on a scale of 1 to 10, right? So those numbers 1 to 10, they're not really numbered. They're not really numbers. They're nominal variables. They're names of a level of pain, right? So in other words, you can't say, if I told you my pain level is 4, another person told you their pain level was 4, you don't know if it's the same level of pain or not, right? Because it's very individual. You have no idea. All you know is that they said 4, right? But the difference there is that 5 is more than 4. You also don't know whether in a scalar variable, a numerical variable, if you have a score of 90, then somebody else has a score of 80, you know the difference between 90 and 80 is the same as the difference between 80 and 70. But with a nominal variable that has order like that, you don't know if the difference between a pain level of 7 and 9 is different or the same as a pain level between 2 and 4. Even though the numbers are the same, you don't know if that really has any impact on it. So there's a lot of things like that. There's a name for that scale. Somebody told me what it was. The safer something scale, right? There's a version of it that they use with kids that have faces, that look like little icons and stuff like that. So emojis, yeah, exactly. Where they start off happy and then they get sadder and sadder and they're crying at the end or something like that. And the kid points to the one that it's them. So. There we go. Exactly. What was that again? Say it louder. Good. Great. Terrific. Thank you. So, okay. Yeah. Okay. So, at any rate, let me get into this PowerPoint and really bore you to death. Okay. So, I hate PowerPoint. Who invented this thing, right? Okay. I'm not going to worry about this. Okay. So, there's our various things. And very frequently, the way that you organize this stuff is in a nominal order, you order into bar plots and bar plots. In other words, the height of bars. The height of the bar represents the frequency, number of people that fall into that category. Pie charts, statistics, we really use pie charts very frequently. Okay, we do use dot plots, histograms, box plots. We'll be looking at those as we move along. Dot plot is just the same thing as a histogram, except instead of drawing a dot, each individual is represented by a dot. And if we have ranges of values, we organize them into groups like 100 to 200 or something like that, and that's called binning. Here's a histogram. Difference between a histogram and a box plot is that for a bar plot, we use for nominal variables because the height represents the frequency. In histograms, we actually are taking numbers and binning them together into groups. So for instance, this might be 100 to 110, 110 to 120, right, whatever. Right, I ran out of boxes, but you get the idea. So if your score is 105, you're right in the middle. You're one of the three people that are in this box, in this bar. If you're 109, you're in this box also. If you are 100 and 109.999, you're still in that box. The minute you cross 110, you're in the next box, right? Notice the difference here. Histograms, they're all connected to bars. In bar charts for nominal variables, there's no reason to connect them because you're not, it's not like a continuous scale where you might flip over into the next box or something like that. So that's a histogram. We usually use histograms for numerical variables. Okay, so sometimes if we got enough data, you can start to see a pattern in a histogram. Okay, and I'm going to there's a video that goes with this that I will post, that goes into this in more detail. But I just want to run through this quickly, and you can see that depending on how you bin it, it can affect the shape and so on. But we're going to start to see that there is very frequently numerical variables. There is a characteristic shape that takes this kind of bell curve shape. And why is that? Well, you think about it. If I'm measuring heights of 10-year-olds or something like that, as I mentioned before, right? Sixth grade. How old are sixth graders? Maybe 12.
Yeah.
12. Okay, so let's say I'm measuring heights of 12-year-olds, right? You measure 100 randomly selected 12-year-olds. You say to yourself, well, most of them are going to be between 55 and 60 inches tall, right? You're going to get some that are less than that, some that are more than that. But the further away you get from that middle area, the fewer and fewer children that are going to be at that height. You're not going to have many that are over 6 foot at 12 inches, right? You're not going to have many that are under 3 foot at 12 years of age, right? So we get this natural kind of distribution. In some cases, we call that a normal distribution based on chance, basically, right? And that's important to us. It's going to become even more important to us. So normal distribution is bell-shaped like this. Sometimes you get a distribution where you have people where you have an unusually large number of people at the high end or at the low end. And instead of getting a nice bell-shaped curve like that, we get something that's skewed like this. So if this were an income scale, right, what this is telling us is that there are a lot of people that are very low income in this population. Not so many that are super high income. Most people are in this range, but it's skewed to the left because there's some people that are very low income, right? And really in the United States, probably look the opposite, right? Right? Because they're the 1%ers that have a lot of income. So the income chart might look the opposite, flipped around them. In other words, instead of being skewed to the left or negatively, it was skewed to the right or positively. There you go. There's one skewed to the right. Right. Most observations are in the middle, but there are few that are on the bottom there. Okay. So what's a box plot? Box plot for numerical variable is a way of displaying the middle and the spread of the data. So here's kind of a distribution of numerical variables, and you can see it has kind of this characteristic bell-shaped curve, right? The way we would display that with a box plot is that we would represent that by the lowest value. This feather would represent the lowest value, and that might be 23, and the highest value might be 70 for this sample that we took, right? What do you think that black line in the middle is? The median, exactly. That's not the mean, it's the median. You guys taken this course before? No? Okay, good. Okay, good. All right, good. So I know a lot of people have taken statistics in ancient history. I took it before I took it in graduate school. I took it in 1967. So yeah, you can bet that by the time I took it again in graduate school, I didn't remember being in 1967. So at any rate, the way this box plot works is that the median is what? The 50th percentile. Half the people are below this, half the people are above this. This box The bottom part of this box represents the 25th percentile. 25% of the people are below it, 75 above it, and the top line represents the 75th percentile. Lowest value, 25th percentile, 50th percentile, 75th percentile, and the highest value. Now this guy over here, he is so far below all of the rest of the people that we're not even sure that data is correct. So if he's far enough out, we consider him maybe being an outlier, a situation where there's something unusual about that person, that subject, that piece of data, that measurement, right? So we highlight that as an outlier. When we draw a box plot, when it's more than 1.5 times the distance between the 75th percent, between the median and the, more than 1.5 times the distance between the median and the 75th percentile or 25th percentile, when it's more than 1.5 times that distance, we term it an outlier. That's kind of a rough rule. You could change that rule. And then we have to say to ourselves, gee, should I include that piece of data or not include it? You have to make a judgment about it. You have to decide why is that so different than all the other data, right? But box plots are nice because you can put them side by side on a table like this. Whoops. I get to it. On a table like this, and it's very easy to see that the median height for females is quite a bit different than the median height for males. And you can see that roughly the variability in height is similar. Maybe males have a little bit more variability in height, but you can see a lot of stuff from this graphic that normally just to see numbers and stuff like that would be a lot more difficult. How are things, you guys okay seeing this behind me?
Yes.
Okay, good. Okay, so numerical variables, mean, median, mode, quartiles, percentiles, range. There's a thing called standard deviation. We're going to get to that. Don't worry about that for now. Okay, the mean. This ugly formula is just the average, right? How does this work? X bar. First of all, number one, I'm calling the mean X bar. Okay, so when I'm dealing with a sample, I always use when I'm describing the range, the mean, the median, the symbols I use for the values for a sample are always regular English. I don't know if they're, are they English characters? Are they Arabic characters? What's the origin of these characters? What's the name of like kanji, Japanese? Anybody know what that is? Right, it must have a name, right? Right, it's right, but whatever it happens to be. It has some origin other than England. Greek, yeah, okay, maybe, yeah, okay, maybe it's Greek. Well, this is certainly Greek, but I mean like our alphabet, like X's and Y's and stuff like that. But then, well, somebody look that up sometime, see what the name for our characters are. So at any rate, we use our characters for that, X, Y, so on and so forth. Standard deviation, we use S. When I'm talking about the same values for the population, I always use Greek letters. So if I talk about the mean of a population, I use the Greek letter mu. That's a little u, right? Lowercase u, right? If I talk about the standard deviation, which is a measure of SPED of the population, I use sigma, which is like a little circle with a tail on it, right? You'll see, well, it'll come up here soon. If I talk about the mean and the standard deviation of a sample, I use X with a bar over the top of it, or I use just simply an S for standard deviation. Okay, so you can see immediately whether it's represents a sample or represents the population. 99.999% of the time, we work with samples because it's too difficult to get the data for the entire population. We're going to be doing that this year, right? Because the census is coming up. But I mean, except for the census, we rarely work with data that involves the entire population, measurement of the entire population. Okay, so in this case, what are we looking at here? We're looking at X. Xi means each individual value for X, each person's weight, let's say. And we want to know that we're going to take the sum of each person's weight from when I represents X1, the first person, up to I represents N, the whatever N is, the 100th person. If N is 100, the 100th person. So this would represent, if there's 100 people, this would represent the sum of the first person, second person, third person, fourth person, all the way up to 100th person. right? And that we're going to take sigma. The Greek sigma represents the sum of. So you take the sum of them, and then you divide 1 over n times that. Same thing as having the whole thing over n. We divide by the sample size, that 100. That's the average, right? That's all this is the average. It's a little intimidating, right? Because I guess we need to make it intimidating. We have some sort of need to make it that way. Okay. Okay. Yeah, so median is kind of a tricky value also. Right, 7 dwarf, median dwarf is number 4. Okay, here you go. The median is resistant to outliers. So let's take a look at the height of these 1, 2, 3, 4, 5, 6, 7, 8 guys, right? If this number 21 was in the locker room when we measured the heights, the average height might be 6 feet tall, right? And the median height might be 6 feet also, right? Some guys are less, maybe 5'8". Maybe the median and the mean height would be pretty much the same. Okay, here comes number 21 out of the locker room, and now all of a sudden the average height is 6 foot 6 inches tall because this guy brings the average up. The mean is not very resistant to outliers. The median hasn't changed much. The median is either still the same guy or the guy next to him, right? It's just changed a little bit. So the median is resistant to outliers, where the mean is not. Okay, here's an example in mode, range. Okay, like I said, I have a more detailed video. I don't want to get too bogged down on this stuff because we're going to actually be working with this stuff. Standard deviation, I'm going to demonstrate that shortly. Okay, so let's get into some interesting stuff. Let's play. Okay, good. Okay, how are you guys online? Any questions online? Let me make sure that everybody's muted, everybody's microphone's muted. Okay, I think we're okay there. So I'm going to go back here and go to the lab exercises. And I'll wait for this to open up. So for now, for this session, I'm going to focus on numerical variables and measuring numerical variables. So here is, anybody want to make up a story for this? You know, every statistical problem has to have a little story made up behind it, some camouflage. I'm going to say that this is blood pressures for measured at senior centers in New York City in patients that are on dialysis that are between 60 and 80 years old. Is that true? No, these are just numbers I made up myself. Not true at all, right? But that's what we're going to say that it is. And now that I've collected this data, I have 18 subjects that I have randomly selected from that population. Do I really want to know what the mean is of this population, of this sample? Is that what I'm really interested in? No. What am I really interested in? I'm really interested in knowing what the mean of the entire population of people in that age range are. That's what I'm after. Why didn't I just do that? Because I don't have unlimited funds. I can't go to every nursing home in New York City and measure every senior that's in that age range that's on dialysis because I don't have the resources to do that. So what am I doing instead? I'm doing what I can to get a good picture of it. I'm getting a sample. I'm investing enough to get a large enough sample to have a rough idea of, or predict what I think the population mean would be, right? So the sample mean, what we're working with here is a sample. So again, X bar, and you'll see me type it in as X bar because it's hard for me to put a bar on top of the X in Excel, but you understand that that just means really X with a bar on top. Okay, so what am I going to do here with this? I want to find the arithmetic average of this column of numbers. Okay, there's a couple of ways I could do this. One is, and I think I introduced Excel last week, right? We did a little bit of work with Excel. I might even be repeating myself a bit here, but I think it's good that since we had such a long layoff, that we do this again, even if we've done it before. So I am going to say, let's see, what can I do? Well, one way I can calculate this, I'm going to add a box down there and put total. I'm going to find the total for this column of numbers. And if you guys remember from last week, the way that you can do a calculation in a cell in Excel is you start by typing an equal sign. Once you type an equal sign, you can do a calculation. For instance, I could do 12 plus 13 is 25. Or I could do that this is equal to um, this value. What is that? That value is A19, the value that's in A19, plus the value that's in A18. And it'll add them together for me perfectly well. Also, I could actually, if I want, I could also take advantage of functions that are built into Excel. And among those functions is this function called sum. Now, where can I find these functions? I can find these functions by clicking on here, and they will come up, a box will come up, Formula Builder. And you can scroll through all the different functions. If you click into any of them, it will give you a window into how they're used and what they do and so on and so forth. I'm not going to, for the most part, we're going to be using a limited number of functions that have to do with statistics. So most of them you'll be able to use and remember. And you'll notice that when I started doing that, when I started typing in an equal sign and typing SUM, I know that exists in here, sum. When I hit the open parentheses, it realizes that, okay, you want to do the sum of a series of numbers, and it gives me a hint. Okay, sum, parentheses, now list the numbers, number 1, number 2, number 3, and so on and so forth. So the way I can do that is I can actually list A1 plus A2 plus A3, or I can actually just give it a range, like A2 through A19. And that will find the sum of the numbers. Okay, that'll find the sum of the numbers in, oops, did I do that wrong? Oh, you're right, A19. Okay, and it finds the sum of them, right? Well, that's a little inconvenient if you have a really big column of numbers and stuff like that. So what you can do to speed this up and make it less likely you're going to make a mistake, put an equal times, type in sum, open parentheses, and now while it's waiting, you can go up to the beginning of that list, click down and drag. And when we get to the bottom, you'll notice that as I do this, it's actually writing in the A2 to A19. It's better because it's harder to make a mistake like that too. And it gave me the same thing. So that's the sum. Actually, there's a function. Now I can see that starts at 2, goes to 19. There's 18 numbers there. But there is in fact even a function here, equals the count, right? Notice how as I type it in, it's giving me hints on the names of functions. And indeed, there is a function called count. And I can click in there, open parentheses, and it will, if I highlight these, it will actually count them for me. So if it's a lot of numbers, that's kind of handy, right? So there's 18 of them. So what is the mean equal to? The mean is equal to the total divided by, and I can click in there, divided by the count. So instead of 79.9 over 18, I can just put in B 23 over B 22. And that's the average, almost 100. I could have also used another function in Excel to do that, right? Now you would think Excel, since it has statistical functions, would have a function called mean. And geomean, hair mean, trimean, none of those, doesn't have it, right? It does have instead average, right? Same thing, parentheses, and then it just wants a list of numbers. Okay, so we actually have a function. I'm having problems with this trackpad, and it's annoying me to death. Click in there and drag down, and it'll fill in the range for me, A2 to A19, and it finds the same average as the other one that I did it. Okay, so now I am going to take that mean. That's the mean. If I want, I can calculate the median. Let's do the median while we're at it. Okay, the median is equal to median. There is a function. Look, there is a function, parentheses, and I'm going to just type it in parentheses, 2, 3, 19. Median's 100, pretty close. Okay, and how did it calculate the median? It actually sorted these and found the middle number. There's 18 numbers here, right? There is no middle number, but you have 18 numbers. You got 9 high, 9 low, right? So what do you do in a case like that? I'm going to put that over there. I'm going to leave it highlighted. I copied and pasted. I'm going to leave that highlighted. I'm going to say edit. I'm going to go say data, sort, and it's going to sort that highlighted column. So now let's see, where would the middle number be? 1, 2, 3, 4, 5, 6, 7, 8. 8, that's 9. That's the ninth value, and there's 9 values above it. It's between 99 and 101. So when you have an even number of values, you take the average of the two middle values. If there had been an odd number of values, you would have had an actual middle number. Okay, so that's what it did. 99 and 101, averaged them, and told me the median was 100. Okay, so I am going to take my mean, and I'm going to say to myself, now I'm interested in, now that I have an idea, two measures of the middle, median and mean, I have an idea where the middle is, let me see how spread out this data is. Okay, and the way I look at how spread out this data is, I'm going to go in here and I am going to find the minimum and the maximum equals, and in fact, there is a function, min, parentheses, and it will, if I highlight these numbers, it'll tell me what the lowest number is. What's the lowest number? We already know, because if you look at that other column, yeah, exactly, giveaway. If you look at the other column, you've sorted it, equals max. And we know what that's going to come out to. Yeah. But was it that high? Yep, 114. And what's the range? The range is equal to the difference between the highest value and the lowest value. The range is 26. Okay, now, remember that interquartile range, that box on our box plot? Let's figure that out now. In order to know what that is, I got to know the difference between the 75th percentile and the 25th percentile. I already know what the 50th percentile is. It's the median, that's 100, right? So we already know that. Okay, so what's the 75th percentile? Is there a function for percentile? And indeed, as I type in here, you see that there is a function for percentile. And when I hit that open parentheses, to help me out, it tells me you're going to have to give me the array, the list of numbers, comma, k. If you go into the help function, that f of x over here, and look up this function, percentile, it'll tell you that k represents the percentile represented as a proportion, as a decimal place. 75th percentile is, that k is 0.75. So I'm going to put in the range of numbers. Comma, and k is 0.75. 104 is the 70%. What about the 25th percentile? We'll do the same thing. Range of numbers, the array, and 0.25 this time. And there is our 75th and 25th percentile, and the interquartile range is the difference between these two. Okay, is there a function interquartile range? I don't think so. I'm having a senior moment, I don't remember. No, I don't think there is. Okay, so that's how we would figure that out. You know, you gotta be a little bit careful interquartile range. Don't get too crazy on this because SPSS calculates in a different way than Excel does. So you might see a little difference between, you know, you'd say to yourself, well, why did it come out 9.5 here and 9.7 there? Don't worry about it. On the interquartile range, don't worry about it. It's a difference in the way that they calculate it. This actually calculates where in that, you know, like divides it up into quarters. SPSS turns it into a population, which is it kind of sees it as a representation of a population with a normal distribution, and then figures out where it would be if that population really existed. But so it comes out slightly different number. Don't worry about it. It's a little bit different. Okay, so now that's nice. Gives me an idea of the spread. But remember, there was that funny thing called standard deviation. It's a funny thing, but this value mean and that value, unlike these other measures of variability, that value standard deviation is going to become vitally important to us later on because it has certain properties that these other measures of variability don't have that we're going to want to take advantage of. So we're going to calculate that value standard deviation. There's a few steps we have to go through. So let's say I want to find the variability for each number that's in here. In other words, how far from the mean is each one of these numbers individually, right? How would I do that? Well, I'm going to copy x bar, the mean here, equals 94 point whatever, 99.94 whatever, okay? And now I'm going to take the difference between these two, and that's going to be x bar, x minus x bar. That's going to be x 99 minus 99.44 or whatever. And that's the difference between those two. And I'm going to do it for each one of these numbers. And what is that going to give me? It's going to show me each individual difference between the mean and each of these numbers. If these numbers are have a lot, in other words, if these numbers go from 50 to 300, a lot of variability, these differences are going to be very large. If these numbers are all, let's say, 95 to 105, then the differences between each individual value and the mean are all going to, these numbers are going to be different, right? So that's kind of a measure. If I add them all together, it's kind of a measure of the variability, right? Just like range or whatever it might be. Okay, except I'm using the differences between the mean and each individual value to represent how far from the mean everything is. Okay, so I want to copy this down so I can use it for all the others. Now, normally I could click in here, drag down, and say edit, fill down, and it would copy the number down for me. Unfortunately, actually, it's a good thing. What happens is when you line up numbers in columns in Excel, it thinks you want to do relative calculations. In other words, repeat whatever calculation is here, by moving down a step each place, right? So if I did that here, another way to do the same thing is just hover till it turns into a cross, and then drag this down, and it will copy the value in that cell all the way down. And look what happened. It didn't copy down 99.54. What it did is it started with the mean, but then in the next box it said, oh, you want me to copy 18. And the next box you want me to, and so on and so forth. We don't want that. We want the actual number. So the way you can get around that is to click in there and put a $sign in front of the letter and in front of the number. And what that does is it changes it from what's called relative addressing to absolute addressing. In other words, copy down what's in cell B21 to all these other boxes, but don't advance. Just copy exactly that cell, each one of them. And we'll see this time it's going to work. Okay, and now I can go ahead and do this, take advantage of the relative addressing and have it do the same calculation in each box, so I don't have to do it myself manually. Either I'm getting old, or my 7-year-old computer is getting old. The trackpad's not as responsive. I'm hoping it's the computer and not me. Okay, let's see. All right, there we go. So now I'm going to add all these together. I'm going to get a sum of all the differences, right? And the bigger that number is, the bigger is all the differences, right? In other words, big differences, but sum is going to be very big too. What's the sum going to be when I add these all together? Oh, hang on a second. I did it again. Oh, I didn't clap my ears. There we go. What is this sum going to be? The sum is 2 times 10 to the minus 14. That's really basically the same thing as 0. Sum's 0. Why is the sum 0? Because some of them are negative, some of them are below the mean, some are above the mean, some are positive, some are negative. So they all cancel out. Okay, so what can I do to avoid that so I can get a measure of this variability? Well, one thing I could do is just take the positive value of all of these, right? In statistics, in many situations like this, instead of doing that, in order to get positive numbers that we can add together without canceling out, what we do instead is we square that number. Negative number times negative number is a positive number. Positive number times positive number is positive. So all going to be positive. So I'm going to take this first number and multiply it by itself, square it. Becomes a positive number. Number changed a little, but it's positive. And then I'm going to copy it down. So now all these numbers are positive numbers. So now when I add them all up, take the sum, I'm going to get something other than 0. And again, it did it to me again. Yeah, Apple just announced a bunch of products. Time for a new computer. Okay. And the sum is 892. Let's give that a name. Let's call that the sums of the squares of the differences on the mean. Right? Isn't that what it is? It's the sum of all the squares of the differences between the mean and each individual value. In statistics, they have a shorthand for that. They call it sum of squares because they use this calculation a lot. right? So they, anytime you use something a lot, you give it a shorthand name. Okay, so now let's say that's nice that that's 892. But what's the average difference between each value and the mean? Well, I just find the average for each one of these differences. In other words, just take 892 and divide it by 18, right? Just like we got the mean. So I'm going to do that, except another tricky little thing. Instead of dividing by 18, they divide by the sample size minus 1. They divide by 17 instead, okay? There's going to be a reason for doing that. We don't have to worry about that right now. That's called degrees of freedom. A simple way you might look at that, we're dividing, rather than dividing by the sample size, we're dividing by the number of degrees of freedom. So if I were to give you a bag, and in that bag I put the number 11, I told you reach in there and pick a number. How many degrees of freedom do you have? You got no degrees of freedom. It's just got 11, and it's what's going to come out. Well, now what if I put two numbers in, 11 and a 17? Well, now you reach into that bag. How many degrees of freedom you have? One. Could be one or the other. So pretty much universally, the number of degrees of freedom is one less than the total number of choices you have, right? So that's basically a rough idea of how you might look at that. So you divide by the degrees of freedom, n minus 1. So I'm gonna find that. So the average sum of the squares of the differences is 52. We have a name for that. We call it the variance. Okay, that's how we calculate the variance. Now, the only problem with the variance is 52. Look at the differences: 1, 10, 9, 6, 5. This number is 52. To bring that number, that variability, that measure of variability, bring that number back into the range of the actual distances, what got us into this fix that it's so big? We squared the number. Now we're going to find the square root of the variance. So the standard deviation is just simply the square root of the variance. Square root, SQRT is the function, parentheses. I'm going to click in there, find the square root. And the standard deviation, this number is going to be so important to us, is 7.25. Okay, that's important to us. Okay, now I'm going to take this set of numbers here. I'm going to say copy. And I'm going to go down here. I'm going to paste it down here. And everything we just did, you already saw mean and stuff like that. Everything we just did, you could also do with using the functions in SPSS. For instance, the variance, parentheses, VAR, whoops. It's really frustrating. Is same thing we've calculated, the standard deviation. Find the square root of that, or you could just ask it for the standard deviation. STDEV happens to be standard deviation. Here we go. And it was 7.7, right? So there it is, 7.25, right? Same number. So we can use built-in functions in Excel to calculate these values, percentiles and so on and so forth, and variance and standard deviation. So why did I go through all of this when I could have just done that? The reason why I did that is because then for the rest of your life, you would never know where this variance is, what the sum of squares was, where the standard deviation of the variance is. Now, if somebody stops you in the subway and asks you, where did this stuff, variance and standard deviation, come from, you can go through this explanation with them. Okay? So at any rate, that's why we did this as an exercise in understanding where this stuff came from, but we can actually use this stuff. Now, what about, it's very interesting that I can do this. Now, I'm going to take these numbers again, I'm going to copy them again. And I am going to open SPSS. Now, I know that you guys don't have SPSS yet because they are dragging their goddamn feet on the license, I mean, can I tell you? In fact, I couldn't get it. I had to go into ICIT and beg them to update mine. I haven't opened it, so I'm not even sure it's going to work. So let's see. But they promised me that they will have it soon. I guess if you don't want to wait, you could use virtual desktop, and I'll see if I can't get on there right now to give you an idea how that works. Okay, you get this opening window, which is kind of an introduction. You can open files from here. It'll give you the files you've used recently and stuff. It's kind of like when you open Microsoft Word, you get open templates or something like that. you can make that go away. There was actually a checkbox there that says, don't show this again. You don't want to use that. So I just opened this, and this opens up. It looks a lot like Excel, doesn't it? It's nothing like Excel, nothing at all. You don't, these boxes, you can't click into them and put stuff in there randomly and so on and so forth. The way this is structured, these cells are just storage for information. The columns represent variables. The rows represent subjects or individual measurements and so on and so forth. So if I had 10 people and I had their first name, last name, age, weight, BMI, blood sugar levels, each one of those variables would be a column. But each row would represent a person, right, going across. Like that data would be in there. So I'm going to drop this in here. I'm going to just go over there and I say Control V or Command V, copy paste into here, and it copied those numbers in there for me. You could just literally type in numbers in here or just cut and paste, paste numbers in here in this column. So in this column, as soon as I did that, notice what it did there. I can't, unfortunately, this is not a cooperative program with Excel and even a piece with Macs or even with PCs. Normally, most programs I could just go like this and expand the size of this. But unfortunately, it's IBM is more interested in the data than I worry about the interface, unfortunately. So it's non-compliant. So I can't really blow this up to make it easier for you to see. Hopefully, it's not too bad back there. Right? That's pretty big. That's a nice, big, bright screen anyway. So at any rate, now we have the numbers in here. Notice as soon as I paste them in there, that little gray VAR changed into VAR0001. It gave that variable a name. I didn't tell if it was blood pressure. I didn't tell if it was blood sugar, lead level, or whatever. I didn't tell it anything about the data, but it needed to give it a name, some kind of name, right? So it made one up, right, by itself. We might want to change that into what it really is. I'm going to call it blood pressure. So there are two views that you can see in this opening sheet in SPSS, the data view and the variable view. This is the data view, and if I click down here, it's the variable view, back and forth, right? And if I go up here, if I go to view, you can change between the views up here too. Data view, variable view. When I go into variable view, you'll notice that there's one row because for each variable, there's a row. The first row, the first column is the variable we're working with. That's the only variable. That's why they only have that row filled in. Okay? And so what's a variable name? It's VAR. I'm going to change that. I'm going to change that to something a little bit more. It should BP for blood pressure, right? And what kind of variable is that? Well, it's numeric. It's a number, right? Okay, it's a number that's in there. That doesn't mean it's a numerical variable. It could be male and female, but we're representing it with one being male and two being female. So it could still be a number, be a nominal variable. So this column doesn't really tell you too much, only that it's a number that's in that box. And we could notice how it added 2 decimal places. That's because by default, it assumes everything it wants 8 spaces before the decimal place, 2 spaces. After the decimal place, here's the decimal place here. I could, if I want to, and since they're all whole numbers, I could change that to 0 if I want. Or I could change it to 4, number decimal place, whatever. I'm going to put it 0. Now, the next box is called label. Okay, now, BP, that's not very, some people may not recognize what that means. This is our opportunity to take our variable name. Now, variable names in SPSS can only have letters and numbers in them. They can't have special characters, and they can't have spaces. Like we can't call it blood space pressure, right? We could call it blood pressure, all the way across, but it can have letters and numbers, no special characters, no asterisks, no nothing, no dashes, right? And it has to start with a letter. It can't start with a number, right? And it has a limited length, although nowadays with the new versions, it's like ridiculously long, so you won't worry about that. But I may not want, if I create a table or a chart, I may not want the description to be BP. I might want it to be more descriptive, right? Okay, so in the label, I have the opportunity to tell it what I want it to print on various output, instead of BP. So I'm going to type in here blood pressure for elderly dialysis patients. But I want that as a variable name? No, probably not. But that's a good descriptive name that we could use on the graph. Okay, what's next? Values. Values, remember I told you if you were working with nominal variables, you could call them male 1 and female 2. Be easier to type that in than male and female if you were typing in data. Use this value label, use it for nominal variables. In fact, if you want to tell SPSS, 1 is going to represent male, 2 is representing female. You can put it in here. We'll get a look at that in a second. Now this is where you can tell missing column, you can tell it what to do with missing values. Okay, and on this, if you just click that, it ignores missing values. It doesn't worry about it. Otherwise, you could actually code missing values with why they're missing. So for instance, I could put in here 99 and 999, and whenever you find, you could say 99 represents, well, they wouldn't tell us, they wouldn't let us measure their blood pressure. Or 999 might mean I forgot to measure the blood pressure or something like that, right? So you know why the data is missing. Okay, so, but we'll assume there's no missing data or ignore it, whatever. Number columns is the number of digits that you're going to display. The alignment, right, left, center, if you want to align the data, and so on and so forth. And then finally, the next really important thing is measure. Measure is the way you tell it the variable types. You remember the 3 variable types I mentioned? Scalar, ordinal, and nominal. So this is a scalar variable. This is where we tell SPSS the scalar variable. Very important we get that right because that determines how SPSS handles the data. So I'm going to go back to the data view. And here we go. Here's our data. Notice it changed to BP instead of what we had there before, VAR, whatever. Okay, so now I'm going to want to do our descriptive statistics with numerical variables. So I want to do an analysis. Well, let me think. What do I got up here at the top? Transform, data, analyze. That's a good place to start, right? Analyze. And what do I go now? Descriptive statistics. Hey, sounds like a natural, right? We want descriptive statistics. So descriptive statistics, frequencies you often use for counting stuff, nominal variables. Not always, but there is some stuff in there for numerical variables. But often you use that for nominal variables. Descriptives, that sounds promising. I'm going to click on that. So now we get a box that comes up. In this box, we see all of the variables that are available here. Okay, so there's only one variable here, blood pressure, BP, right? That's the only variable that we have in this data set, right? If we had 7 variables in this data set, they would all be listed here. So this is my chance to tell SPSS, the variable I want to work with is, and move it into the other box, is blood pressure, right? I would pick one or both, or 1 or 2 or all of the 7 variables and move them over where I want to. I'm going to go into options. Options say, it's going to calculate the mean, standard deviation, minimum, maximum. Let's calculate the variance. Let's calculate the range. That looks like about all I'm interested in. So I click OK. I click OK. And what we did in Excel now is repeated in SPSS in seconds, literally in fractions of a second. Okay, so what do we have? We have 18, count as 18, the range is 26, minimum and maximum, same thing. We got mean, standard deviation, variance, all the same numbers we got before. Okay, so pretty interesting, right? That's pretty useful to us. Okay, so now notice that it doesn't say BP over here. It says blood pressure for elderly dialysis patients. That's what filling in that label area did for us instead of putting BP in there. Gave us a better description. Okay, so now, that's interesting. Maybe I can get more statistics. Well, in fact, if I go up here to Analyze, Descriptive Statistics, and I go to Explore, the next choice down, now it comes up again. There's a few more boxes. Don't worry about that for right now. I'm just going to go in here and I'm going to move that over. And now I'm going to go into Statistics, and it just says Descriptive. It doesn't tell us to do a lot of choices because it's going to do plenty of stuff for us. Oh, let me check into Plots. Oh, gee, plots, I can ask it to do a whole bunch of stuff. It's already going to do a couple of things. How about histogram? Let's get a histogram. I'm going to click continue, and I'm going to click OK. What's going to happen now? Now, notice that this window where these results are coming in is a different window than our data window. The data window is separate from the output window. When we're done and we want to quit SPSS, if we want to save the output window, we have to save it separately from the data window. If we save the data window and don't save the save the output window, don't save the data window, then we will wind up losing the data that we put in there, right? So, or any changes we made in the data, right? So what do we have now? We were saying 99 before, we got this whole 9 thing. We have many other things besides this, a range, and so on and so forth. And look, here is our histogram for these patients. The blood pressure looks kind of like a normal distribution, right? Kind of. Here's our box plot for this blood pressure for elderly dialysis patients. Well, why is this of any value to us? It's very interesting. But now, what do I do with this if I want to use this? If you save the output window, it comes out as a .spv file, an SPSS output file. Not much use to anybody except you or somebody else that has the same version of SPSS. So we need a way to share this information if we want to use it in a report, a capstone, whatever. So one way we can do this is that we can go up here to File, when we have the output window up, File, and we can say Save As, and we can tell it to save it as an SPV file, or we can tell it to save it as a web report, and so on and so forth. That's not what I want. I want to go back again. I can go to File, I can say Export, and I can export it as, among other things, I can export it as a Word or RTF document. So it will convert all of these tables and charts into a Word document. Okay? It just saved it somewhere. I wasn't paying attention to where it was putting it. Okay? The other thing that we can do is even more useful, and that is I'm going to open a Word document. I left off the E. We could repeat that. Oh, by the way, if you want, you can actually go in here and actually double click on these things and edit them. You know, like change colors in the chart and so on and so forth. I don't want to get into that right now. Okay, so where's my Word document? Here. Okay, this came up too. I don't need this. Okay, blank document. There's a Word document. Okay. Okay, what is this? This is my brilliant, not so brilliant, capstone. Okay, and let's say I want to put some data into this capstone project. I can go back to my SPSS output, and I can say, well, you know, this table is pretty important. I'm going to click on that. Notice now it has an outline around it, means it's selected. You can go to Edit and Copy. You can also use Control C or Command C on Mac. Go over here, and I'm going to say Paste. You can say Paste Special, and you might get more than one choice. In this case, you don't. Just get text. So I can go ahead and just say Paste. Now, here's the table imported into my Word file. Okay, now, what about the charts? Let me take this box plot here. Notice it's highlighted now. Edit, copy. And then I'm going to go back into my report. And I'm going to say paste. Paste special maybe. And I have a few choices, a TIFF, a JPEG. Put it into JPEG, a small file. And there it is. I got the word blown up here. That's why it's so, the view is so big. There we go. Okay, so you can take your data that you've gotten in SPSS, your calculation, and put them into your Word document. Okay. First exercise, first homework. It's going to be split up into 2 parts. I posted it already. Yeah, the first part is general kind of stuff, right? Just multiple guess kind of stuff. The second part is problems that you need you to use Excel or SPSS. That's why I broke it up into 2 parts, because I know we've had this issue with SPSS. if you want, you can just do the Excel part if you don't have access to it. Now, just so you know, there is a way for you to get access to, I wish I knew off the top of my head, SPH, look at it, virtual desktop. You know, I had it installed on my machine. I think you have to do a brief installation, a plugin. Yeah, you got to install it on your computer. I'm not sure may still be installed on my computer. Okay, so I went to this website, virtual desktop applications. I just Googled SPH CUNY virtual desktop. I just did that, and it took me to the virtual desktop applications. Now, to use it, you have to install a plugin on your computer, and I think it's installed on mine. I don't know. Then you have to log in with your CUNY first ID and so on and so forth. So I'm going to see if it works for me. I'm going to click on this, okay, and see if it opens up. If the client's still installed, and let's see. System will be unavailable from Saturday. I don't care about that. Okay, now it's waiting for my password. My password, I think, is going to be the same as it is here. Let's see if this works. This is too much to hope for, right? Take a look at it. Yeah. At least on the Mac, you get a beach ball. No, that's no good. Okay, so maybe it's my whole, maybe it's this. Let's try this. You would think if it's not me, up, that was different, right? I think that worked. So it's going to come up. And in this virtual desktop, I'm actually on a Windows computer, right? It's as if my screen, my keyboard, and my screen are actually on another computer somewhere in the cloud. And it's going to open up, and one of the things that's going to be there is SPSS. I'll be able to run SPSS. It can get a little confusing because when you open and save files, you got to remember when you say file open, you start browsing, you might be on their computer, you might be on your computer. Okay, so where is it? Oh, you've used it before. Oh, there. Okay, here we go. Yeah, I've been studiously staying away from this because I just don't have the patience for it. Right? Because it's slow. Look how, it's going to be slow compared to just having it on your own computer, right? But it's okay. It's free. Slow, free. Slow is good when it's free, right? And at least it'll buy you some time until they get your SharePoint version of it running and stuff, so you don't have to go out and spend the money on it. Well, I mean, it's 50. I can't buy the student version. I can only buy the faculty version, which is like $300 or something like that. Yeah. So the program itself costs, just even the lowest level version of it, the standard version, is like $800 or $1,000. And that's just the start. There's also the plugins and add-ons and so on and so forth. So you can see it's a bit slow. So what's going to happen is SPSS is going to open up on here, and we can say File, Open. And where we're going to find the file? Well, you have to navigate off their system to your desktop. Click on that file. It'll import that file, and you can work with it, and so on and so forth. And when you're done with your output, okay, like in other words, I can still, you can save it. You can then at the end save it as an RTF file or something like that, a Word file, so you have all your charts and data and so on and so forth. So now, if I could just click on here and create a new data set and type the numbers in, right, and then get the output and so on and so forth, or I can open another file. So I'm going to say, actually, I'm going to make this go away because I don't need that. I'm going to do it right from here. I'm going to say File, Open, Data. Okay, and I'll see if I can't navigate. So right now it's in Documents. That Documents is in Anthony DeVito 95, right? In the users, local disk, that's on that computer, right? It's a Documents folder in that computer, not my computer. Okay, if I go over here, Tony DeVito and Anthony's MacBook, if I click on that, now I'm looking on my MacBook. Right? See what I'm saying about it's a little bit tricky to navigate around. And now I'm on, oops, not quite yet. Now I'm on my MacBook, and that looks completely unfamiliar. I think it's still loading. I can see music. You wonder why I don't use it. You know, if you just type the numbers in, you won't have this problem. Okay, one of the tricks here is that, how come I don't see it? What is this? Let's see. Desktop, how about computer? So, you don't think so? It says on Anthony's MacBook. That's my MacBook. And I see the music folder. I just don't see why I don't see the rest of it. I have to be able to navigate to my computer in order to be able to put data in there, in order to open data. How about desktop? Computer? That should be it. Yeah, I don't know why it's the way it's doing it. I don't want to kill too much time on this. You can monkey around with this. If you have a PC, you probably have an easier time with this. But that's the idea, is you got to get the data into this thing. Once you get the data, let me see if I can't paste that. I might still have the data in my, no, it doesn't look like it. It's not pasting. Apparently it doesn't carry over. Okay, so I could actually type in numbers here if I had to. Notice it did the same thing with that, with the variable name, and you can switch to the variable view to hold the same thing. I'm going to go to Analyze, Descriptive Statistics. I'm going to do the simple one, Descriptives. Move it over. Say OK. The output window opens up, gives me that table. So now I want that table, right? So I can go up here to Export File, Export, and choose to export it as a RTF, or rich text file, which is a Word file, and give it a, right now it says use this video. Okay, I want to browse. And I'm going to browse. I'm going to go up here. I'm going to go, yeah, this is definitely my computer. That's definitely my computer. Okay, I'm going to go there, and I'm going to go into the music folder, because it's the only one I can get to. Let's see what it does. And I'm going to save the file there. File name is going to be test. Okay. Save. Okay. And now what I'm going to do is I'm going to go. Okay. I'm going to get out of this. I wish I knew how. Probably go down here. Log off. Good. Okay. Program still need to close. Force log off all. Yes. Okay. And I'm back on my computer. Now I am going to go to my hard drive and see if it came here. Right? That was the only folder I could get into, right? So let's see if it actually showed up there. We'll try this out of the way. Get to my hard drive. You know, I think some people are I've been neglecting the people that are online. I feel terrible about that. I'm going to have to get to them right now. As soon as I check this, I will get to them. Probably half of them had the answer to this, why I can't get to this. And I should have been listening to it. Maybe not. Well, I got a lot of junk on my desktop. Time to clean it up. Eventually, I should get to my hard drive. I can see it back there.
Can you just click on the bottom there? Like that window?
Hey, yeah, I just want to get to, I don't know what all this stuff is. Why do I have all this stuff here? Okay. Okay. Okay, let's see where we are now. User?
On the left-hand side.
Yeah, users, music. And there's my user area, here's music. And date modified. There it is. And there, oops, and there is the table, right? Okay, so it's actually, I mean, it is barely functional. I shouldn't say that. I shouldn't say that. With a little bit of experience, I haven't been using it. I tried it 3 years ago when they first started doing it, and it's actually much better now than then. It's really slow and cumbersome then. So it's actually performs a lot better now than it did then. But I guess it'll buy you some time if you want to work. But I understand if you don't, I'll stretch the due date on the second half of that homework. And I'll try and make the next homework so you don't need to use Excel.
The first half is due at 16.
Yeah.
1A.
Yeah. Remember the deal here. All you have to do is get at least one attempt in by the due date.
Okay.
Right? You don't have to get it right. I just want to make sure you try it by the due date. As long as you do that, you can do it 100 times after that until you get 100 on it. Right? And I only count the highest score. Right? So the homework, you can collaborate on the homework. Homework is for you to learn this stuff. The exams are tests. I'm testing you as an individual. But the homeworks are meant for you guys to understand the stuff. Right? So my objective here is not to use the homeworks to grade you, but to use the homeworks to encourage you to make the attempt, do it, get on the bicycle and ride it. Right? And eventually, and it's to your advantage because it's 40% of your grade is homework. So if you just keep going back and hitting at them, and eventually you're going to get 100, right? That means 40% of your grade is 100. So if you get a 60 on the exam, on the midterm, right? That midterm's worth 15% compared to the homeworks with 40%. It really helps, So, and there are still people that don't take advantage of that, but you really should, right? So that's really the deal. I want you to go and try it. And like I said, if we don't have SV, if you want to try virtual desktop, fine, but I will stretch the due date for the first attempt on the second half or any subsequent homeworks that need it as well. Okay, so let me get back to this and let me just look at the chat box. So far, so good. Okay, so nobody was looking for me there. Okay, that's excellent. Okay, I'm gonna try and get done by 9:45, 5 minutes early, so we get out of here 5 minutes early at least, or maybe another few minutes, because it's late, right? And I don't know about you guys, I haven't had dinner yet, so yeah. But look, when you're all done here, you're gonna have another degree. Yeah. So I'm small pickings around here. I have a master's degree in environmental occupational health science for a lot of years, but I'm small picking. Everybody else works has got PhDs and multiple PhDs, whatever. Depressing. But usually most of them are pretty smart. Notice I said most. I qualified that. Did I qualify that too much? Okay, so at any rate, let's go back to this. So that's really basically what I wanted to introduce here. And there's a couple of versions of this on the videos that you can see. And so, also the lecture, you're going to see a version of it by another professor that you'll be able to read and so on and so forth. I just want to go back here now. And I want to just introduce one thing. I just want to expose you to this, but we'll solve it next week. Hopefully I'll remember having said this next week. Oh, good, excellent. That's good. That's a good thing. But I just wanted to show it to you. Get to it. Okay. Okay. There's a section on study designs also, another video that you guys should watch as well. Remember, this is really kind of a combination of online course. So not everything, we only have, an hour and 50 minutes in here, right? It's not like we have, the full 3 hours that you would do in a brick and mortar course. So remember, this is really still stuff that you should be watching. You have these videos and these other materials and things you should go through on here. So we can't find it. I wanted to start to show you data standard. There we go. Okay, this is what I want to show you. Just as kind of an introduction, get you excited, get you in here next week. Okay, so this Excel file has real data. This is real live data. I think it's about 10 or 15 years old, but it's actual mortality data in New York City. And it's been summarized. It came from the New York City Morbidity and Mortality report, annual summary of its report. And they track what are the major causes of deaths in New York City. So for instance, they track how many deaths there were due to cardiovascular disease, cancer, and so on and so forth. And they group it by different genders and ages and so on and so forth. So you can see that, in the age range 0 to 10, what the most frequent mortality cause of mortality is, infant mortality is, for instance, or from 18 to 25, that's, for males, it's probably accidents, right? Maybe second to suicides or something like that. Those, especially for males, reckless behavior and stuff like that. Females, maybe they're not as high, maybe there's other major causes of death. And then as you get older, you see changes in that. So accidents go down the list, and cancer goes up the list. And as you get into more elderly people, then suddenly you see heart disease and cancer, the top two causes of mortality, right? So at any rate, this focuses on the numbers only by gender and for cardiovascular disease, and only in these age ranges, not all the data. So it had to be kind of accumulated, a little bit of accumulation. So age 24 to 44, in this particular year, this was the population of females in New York City in that age range, population of males in that age range. This is the number of fatalities among women that age, men that age, and men that age, and women that age in New York City during the course of that year. Okay, so if I add all of these together, okay, I'm going to add all of these together. There were 12,000 deaths among females out of a population of 2,845,000 across all of these age ranges. So I'm going to calculate the mortality rate for women in this population. And the mortality rate is equal to, let me get this out of here. Mortality rate for women is equal to the number of women that died over the total population, right? No secret there. Okay, and it comes out to be 0.4% of women. That's the same thing as 4.4 out of 100, or 4 out of 1,000, or 40 out of 10. In other words, if I just multiply that number by 10,000, it's going to give me the mortality rate per 100,000 women. And I could do that for 1 million or for 10,000 or something like that. Whatever's a convenient number to work with. This is a lot easier to work with than describing it as a rate of 0.0044. So the fatality rate for females is 442 in that year per 100,000 females. Okay, what about males? Okay, well, for males, I'm going to calculate it for males, and for males, it's equal to this number of deaths divided by this population, parentheses, times 100,000. Okay, and everybody knows that males are more at risk for cardiovascular disease than females, and their mortality rate is going to be higher. What happened? Lower. Why is it lower? We're going to discuss why it's lower next week. You got a reason to come back next week.
Oh.
Okay, you guys online too. Okay, we're going to talk next week about data standardization and age adjustment. That should be a hint, in terms of like what's